You might have heard the name Apache Kafka, but what is it? And how the heck is it so fast? Kafka bills itself as an event store and stream processing platform. Event stores are a type of database which are optimized for storing, you guessed it, events. What kind of events? Well, how about a ride-sharing app that's looking to match users who are looking for a lift with a driver? Another example would be providing real-time analytics for a smart home. So now that we know what events can be, what about stream processing? Stream processing is a programming paradigm that views data streams, or sequences of events through time, as the central input and output. The two definitions combined, we get a clearer picture of Kafka, an event storage and processing pipeline. So what makes it so performant? Well, first, we can credit the architecture of the application. Kafka is optimized for high throughput as it's designed to move a huge number of events as fast as possible. The first and most important thing to know about Kafka's architecture is that it depends on sequential I/O. Oftentimes we think of disk access as inherently slow, especially when compared to accessing something from memory. But the truth of the matter is that there's two types of disk access: random and sequential. While random access is slow, especially depending on the storage medium, sequential data reads only require initial seek times, and then you should have an uninterrupted data stream. Now, Kafka capitalizes on this fact by using an append-only log. This append-only log can write new data to the end of its file, and by doing so, writes a sequential pattern of data. Next, Kafka's processing paradigm is large volumes of data from network to disk or from disk to network. And in instances like this, zero-copy principles are critical. But what does that mean? Well, typically, when data is retrieved by a CPU, it will often copy the data into a buffer and then pass it along to another process or a piece of hardware. This process can be not only slow, but also wasteful. Zero copy describes the process of eliminating unnecessary copying of data from one area of memory to another. This saves CPU cycles and memory bandwidth for other critical processes. Next up, let's talk about Kafka's optimized data pipeline. Now, data is paged from disk to the operating system cache, but then Kafka calls the OS's send file function. This function skips the step of copying the data into Kafka's allocated memory and moves it instead into the network card's buffer. With modern network cards, this can be further optimized with DMA or direct memory access. DMA skips the CPU being involved at all and allows the network card to read the data in memory independently. Now, Kafka is meant for massive enterprise-scale datasets. You can pass user activity, metrics, system logs, events, and messages to Kafka, and rest assured that the data is stored without ever worrying about overwhelming the server. And when comparing Kafka to the competition, it has better throughput, built-in partitioning, replication, and fault tolerances. So how are businesses leveraging Kafka to meet their enterprise-scale needs? Airbnb utilizes Kafka's event pipeline for exception tracking. Shopify uses Kafka to handle their logs, domain events, metrics, and customer reporting. Square's Kafka implementation touches all of their critical systems, moving all events through various data centers. And finally, Firefox's telemetry system relies on Kafka's high throughput to collect and analyze usage statistics and test results. So are you ready to stand up your own instance of Kafka? We've got you covered with our comprehensive Apache Kafka documentation. Use the links below to get you started. That's going to do it for today's video. Make sure that you get subscribed and stay tuned for more videos just like this on how to best set up your architecture for your business or application.